welcome back to the channel. In the previous lecture, we have seen how to find the complementary function of higher order linear differential equation with constant coefficient. आज के लेक्चर में हम ये देखेंगे कि पर्टिकुलर इंटीग्रल कैसे फाइंड करेंगे. Okay, so let's see what is particular integral and what is the formula of particular integral. So particular integral here, particular integral of higher order linear differential equation with constant coefficient, that is f of d into y, which is equal to x, is given by yp is equal to 1 upon f of d into x. Okay, so this is the formula to find the particular integral of the given higher order linear differential equation. So py, a particular integral, that is yp, is equal to 1 upon f of d into x. Okay, so now if suppose we have x is equal to 0, or in particularly if we have value of x as 0, so for them how we can find this? So note in the equation f of d into y is equal to x, if capital X is equal to 0, then particular integral, that is yp, is equal to 1 upon f of d into x, which is equal to 1 upon f of d into 0 is equal to 0. Okay, so अगर कैपिटल X की वैल्यू 0 है, so इसका पर्टिकुलर इंटीग्रल 0 होगा. So therefore its complete solution, that is y, will be equal to yc plus yp, and in this case our yp is 0, so implies y will be equal to yc only. Okay, so अगर कैपिटल X की वैल्यू 0 है, so पर्टिकुलर इंटीग्रल 0 होगा. In that case the complete solution will be equal to its complementary function. Okay, so now let's see some problem based on this one. So here I'm going to take some problems. Okay, so problem number 1. Problem 1. Solve d raised to 4 plus 5d cube plus 5d square minus 5d minus 6 into y, which is equal to 0. Okay, so we have this question. Now to find its complete solution, we have to find particular integral and complementary function. So in the previous lecture we have seen how to find its complementary function, and today we are going to solve how to find its particular integral. So in this one we have to find both to get the complete solution. So solution, okay, so first हम क्या find करेंगे? Complementary function. So the auxiliary equation is d raised to 4 plus 5d cube plus 5d square minus 5d minus 6 is equal to 0. Okay, so this is our given question. Now this is d raised to 4 plus 5d cube plus 5d square minus 5d minus x is equal to 0. So now by solving this differential equation we get the roots as d. So here d is equal to, we have -1, -2, -3 and 1. Okay, so we have 4 roots here, -1, -2, -3 and 1, and since all roots are distinct, so therefore roots of auxiliary equations are -1, -2, -3 and 1. Since all roots are distinct and real, so therefore its complementary function yc is equal to c1 e raised to -x for -1 के लिए जो -1 रूट है उसके लिए आ गया हमारे पास c1 e raised to -x प्लस जो -2 रूट है उसके लिए आएगा c2 e raised to -2x प्लस c3 e raised to -3x plus c4 e raised to 1x, that is e raised to x. Okay, so this is our complementary function. Now we have to find particular integral. तो particular integral के लिए for particular integral, okay, so yp is equal to 1 upon f of d into x, and here see on the right hand side x is equal to 0, so which is equal to 1 upon f of d into 0 which is equal to 0. so इस क्वेश्चन में पर्टिकुलर इंटीग्रल की वैल्यू 0, so therefore complete solution y is equal to c1 e raised to -x plus c2 e raised to -2x plus c3 e raised to -3x plus c4 e raised to x. This is our solution. Okay, now let's see one more problem and let's see how we can find its solution. Okay, so let me write the next problem first. So problem number 2. Okay, suppose we have the second problem as solve d cube minus 3d square plus 3d minus 1 into y which is equal to 0. Okay, so we have this differential equation and we have to find the solution of this differential equation. So solution, so पहले क्या लिखेंगे हम, auxiliary equation. So the auxiliary equation is d cube minus 3d square plus 3d minus 1 is equal to 0. Okay, so as we know that how we can use calculator in examination, so I can write the direct root here. So therefore d is equal to, since it is a polynomial of order 3, so it means we have 3 roots here, and by solving this differential equation by using calculator or any manual method, so हमें मिलेगा d की वैल्यू 1 1 1. Okay, so 3 roots and all roots are repeated, that is 1 1 1. So therefore roots of auxiliary equation are 1 1 1. Okay, तो सारे रूट्स क्या है, repeated और real. So therefore complementary function yc is equal to c1 plus c2x plus c3x square into e raised to x. ओके, हम रूल नंबर कौन सा यूज करें? थर्ड वन, मीन्स 3 रिपीटेड रूट्स. ओके, दिस इज आवर कॉम्प्लीमेंट्री फंक्शन. अब क्या फाइंड करेंगे? इसका पर्टिकुलर इंटीग्रल. सो फॉर पर्टिकुलर इंटीग्रल, फॉर पर्टिकुलर इंटीग्रल, so yp is equal to 1 upon f of d into x. So as we know here, value of x is 0, so 1 upon f of d into 0, which is equal to 0. Okay, so particular integral is 0, so therefore complete solution is y is equal to yc plus yp. So yc is c1 plus c2x plus c3 plus c3x square in bracket e raised to x plus 0. So this is our complete solution. We have seen how we can find the solution of the given higher order linear differential equation with constant coefficient. तो उसमें हम करते क्या थे? सबसे पहले हम फाइंड करेंगे उसका कॉम्प्लीमेंट्री फंक्शन, फिर पर्टिकुलर इंटीग्रल, फिर दोनों को प्लस कर देंगे. ओके, so now we are going to follow the same, but here just we are going to solve the problems which has complex root. Okay, so first problem I am going to take here. Problem number 1. Okay, so solve. Suppose I have question d cube y upon dx cube plus 8y which is equal to 0. Okay, so solution. So first let d by dx is equal to d. इन द वेरी बिगनिंग, बहुत ही जब हमने मॉड्यूल स्टार्ट किया था तभी हमने देखा था कि d अपॉन dx को हम क्या लिखते हैं? कैपिटल D. सो बाय यूजिंग दिस वन वी कैन राइट d क्यूब अपॉन dx क्यूब एज कैपिटल D क्यूब. ओके, सो देयरफॉर our equation will become d cube into y plus 8y which is equal to 0. So this is in the form of f of d into y is equal to x. Okay, so now by taking d cube common here, plus 8 into y which is equal to 0, this one. Now so we have to find its complementary function and particular integral. So let the auxiliary equation is d cube plus 8 is equal to 0. Okay, and we know that d cube plus 8 is equal to 0 implies d cube is equal to minus 8 and d is equal to minus 2. So we are here, since it is a polynomial of power 3, it means here it will have 3 roots. First root is minus 2 and 2 root will come in the form of complex. Okay, so therefore d is equal to, first I am going to write complex part first. So 1 plus root 3i, second 1 minus root 3i and third one minus 2. ओके, तो इसके 3 रूट्स होंगे. फर्स्ट रूट है 1 प्लस रूट 3i, सेकेंड रूट 1 माइनस रूट 3i एंड थर्ड रूट minus 2. Okay, now since here we have 2 complex root. Okay, so हम फोर्थ फॉर्मूला यूज करेंगे जो हमने स्टार्टिंग के लेक्चर में देखा था. सो यहाँ पर अगर ध्यान से देखो तो 1 प्लस रूट 3 आई है। सो यहाँ पे अल्फा की वैल्यू है 1 और बीटा की वैल्यू रूट 3। ओके, सो इट इज इन द फॉर्म ऑफ अल्फा प्लस आई बीटा, करेक्ट। सो अल्फा की वैल्यू 1, कॉम्प्लीमेंट्री function is yc is equal to e raised to अल्फा इंटू एक्स। अल्फा की वैल्यू है हमारे पास यहाँ पर 1, सो 1 इंटू एक्स, ओके, इन ब्रैकेट c1 cos बीटा एक्स, बीटा की वैल्यू रूट 3, सो रूट 3 इंटू एक्स प्लस c2 sin बीटा x, ओके, ब्रैकेट क्लोज। एंड फॉर द थर्ड रूट -2 जो है उसके लिए लिखेंगे हम c3 e raised to -2x. So this is our complementary function. Okay, now see, since here we have capital X is equal to 0, so इसका मतलब क्या हो गया, जो इसका particular integral होगा वो 0 होगा। So therefore y p is equal to 1 upon f of d into x, which is equal to 1 upon f of d into 0, which is equal to 0. Okay, so थोड़ा सा इसे हम ऊपर लेते हैं। Okay, so therefore complete solution is y is equal to particular integral plus complementary function. So यहाँ complementary function है e raised to x in bracket c1 cos root 3 x plus c2 sin root 3 x bracket close plus c3 e raised to minus 2x plus particular integral is 0. So this is our solution. Okay, so now we can see one more problem based on the roots which comes under complex part. Okay, so now let's see one more problem. So suppose okay, solve d raised to 4y upon dx raised to 4 plus y is equal to 0. So solution for this differential equation solution, so let d raised to 4 upon dx raised to 4, which is equal to d raised to 4, capital D raised to 4. Okay, so therefore same equation we can write d raised to 4 into y plus y is equal to 0. Okay, now I can take y common, so d raised to 4 plus 1 into y is equal to 0. So this is in the form of f of d into y is equal to x. Okay, now we'll find complementary function and particular integral here. So for CF, okay, first we'll solve for CF. The auxiliary equation is d raised to 4 plus 1, which is equal to 0 here. Okay, so now by solving we'll get root of this polynomial as 1 by root 2 plus minus 1 by root 2 I, and second one minus 1 by root 2 plus minus I into 1 by root 2. Okay, so we have this one. It means here we have the four roots, 1 upon root 2 plus 1 upon root 2I Second one, 1 upon root 2 minus 1 upon root 2i. Third, minus 1 upon root 2 plus 1 upon root 2i, and the last one minus 1 upon root 2 minus 1 upon root 2i. So let me write here. So therefore roots are, so d is equal to here, let me write the root here only. So 1 by root 2 plus 1 by root 2 I. Second one, 1 by root 2 minus 1 by root 2 I. Third one, minus 1 by root 2 plus 1 by root 2 I. And the fourth one, minus 1 by root 2 minus 1 by root 2 I. सो ये टोटल 4 रूट्स हैं हमारे पास. अच्छा, अब देखो यहाँ से अगर हम देखेंगे 4 रूट से चारों कॉम्प्लेक्स में और चारों डिस्टिंक्ट है, बट ये जो फर्स्ट दो है कॉम्प्लेक्स कॉन्जुगेट है. सो फॉर देम वी कैन राइट हियर. सो जस्ट लेट्स सी हियर. सो फर्स्ट these two we can write here. So therefore complementary function yc is equal to, here alpha is equal to 1 by root 2 and beta is equal to again 1 by root 2. So we can write e raised to alpha into x in bracket, we can write c1 cos beta, that is 1 by root 2 and x. So I can write here x by root 2 plus c2 sine x by root 2. Okay, this is for first two, plus now for the next two I'll write here, since here alpha is minus 1 by root 2. So next one I can write here e raised to minus 1 by root 2x in bracket, we can write c3 cos, and again here beta is what, 1 by root 2. So I can write x by root 2 plus c4 sine x by root 2. Okay, so this is our complementary function. Now we have to find its particular integral. So for pi, yp is equal to 1 by f of d into, I can write directly here 0, so which is equal to 0. Okay, so therefore complete solution is given as y is equal to, complementary function first we'll write. So I can write here e raised to x by root 2, okay, in bracket c1 cos x by root 2 plus c2 sine x by root 2 plus e raised to minus x by root 2 in second bracket c3 cos x by root 2 plus c4 sine x by root 2. Okay, plus 0, and plus 0 करो या ना करो बात एक ही. So this is our complete solution when we have complex root. Okay, so just go through the whole solution, you can see or you can go through it by revising, or if you are stucking somewhere, so you can stop the video, just go through, understand it, then proceed further.